So let's think about using this process to value a really simple project. So we'll have, this is XYZ company is thinking about project A. So they're doing something, and here's how it works. So we've got, these are the cash flows. We have a year 0 cash flow and year, 1, 2, and 3. Let's change this format to be just a number. So we have cash flows, and let's suppose that we are paying some amount of money, say $150, and in exchange for that we're going to get 50, 60, and 70. These cash flows are the same as, and conceptually, as what we've just been doing. So we have a year 0 cash flow, a year 1 cash flow, and we can determine how much 50, 60, and $70 arriving at these times is worth today at time 0 using the discount factor. So if we define a discount factor of 1.05, the market rate of interest is 5%. Well, how much is negative $150 at 5% interest if we have to pay it today? It is negative $150. Right? That doesn't change. That's money we owe today. The interest rates don't affect it. $50 in 1 year is, using the discount factor, 50 divided by our discount factor. Oh, $50 in year 1 is equivalent to $47.62 in year 0. Meaning that if I invested $47.62 at the market rate of interest, I would have 50. Those two are equivalent via that process. Now what about the 60? So the 60 is in year 2. If I take the 60 and I divide by our market rate of interest, that takes it back 1 year. So assuming the market rate of interest from year 1 to year 2 is 5%, we would use a 5% discount rate, and we get $57.14. But this, now bear in mind, that's 1 year earlier, right? This is $60. A year's worth of interest would reduce it to $57. This is now year 1 money. So to get to year 0, we have to do the same thing again. We have to divide again by the discount factor, because this is year 2 money, this is year 1 money, and this is year 0 money. And we want to deal exclusively in year 0 money. Naturally, we're going to have the same thing here. So I'll divide by the discount factor, and then do it again, and do it again. But these $3 amounts are now all year 0 dollar amounts. I would be willing to pay $60.47 to get 70 in year 3. I'd pay $54.42 to get 60, and $47.62 to get 50. I can combine all of these now because they're all effectively in the same units. They're all year 0 cash flows. So if we split this up into 4 different pieces, we'd have $4 amounts, and then we can determine whether these positive cash flows are worth enough in present value to justify a $150 expense. So naturally we add them. I get this much in present value from year 3, this much in present value from year 2, this much in present value from year 1, and I lose this much in investment. That $12.51 means that the cash flows which exceeded the initial investment by $30, produce a net benefit to me in present value of $12.51. So in the same sense that $105 today is better than $110 tomorrow, 50, 60, 70 in this time frame is exactly $12.51 better than $150 today is. And that's the objective framework we'll be using to evaluate cash flows that arrive asynchronously in time. So this is a simple project over several years. You could naturally extend the years more, have multiple accounts, have different discount rates depending on the years. So there's a way to make it more, there's plenty of ways to make it more realistic and more complicated, but at its core what we're really dealing with is using the market rate of interest to find a reasonable today price for money arriving in the future.